Hello everyone, welcome to my Physics one-on-one experiment. My name is Alp Güvenç. My department is Electrical Electronic Engineering. Today, in my experiment, we try to see that normal potential energy converts to spring potential energy. So we need a wooden block that has a sinus value on it, a waiter, airtable puck, and spark timer, and spring and for stabilizer I use the wooden block again. Okay, so firstly we need to calculate the weight of the pucks because of the potential energy conserved. So as you can see, this is 435 gram this puck is, and okay. For spring constant, there are a lot of tools in internet, or there are a lot of websites in internet to calculate the spring constant. For instance, you need to you need to know the materials of your springs, how much curve is it, and how much distance between the curves. You need to know that, and you can calculate the spring constant. Okay, we need to find how much stable this part on this air table. So you need to adjust the balance of the air table. But you can't, it can't stop right here perfectly because there are a lot of factors about this. Maybe this tube can push the puck itself because its friction is too small, so it can move too easily. Okay, we put the spring here. Now we use the wooden block. There is a sign value on this block. I'm using 0.16. So we are using different types of this paper. So you need to adjust the spark timer to 20 milliseconds because if you adjust the more, it can give more error percentage. So be careful about that. Okay. Now we are starting the experiment. Okay. Okay. Now you need to know where was this spring in the beginning and how much this puck has a distance from it, because you need to find the center of the puck because it gives electrical from here. So you need to find the distance from here, and you need the middle point of this, so you can know how much it goes from this. For instance, it goes there. Maybe it's not looking like in the video. So its middle point here. This puck has gone here. So if you calculate this, it has the 5.5 distance from the displacement in the center. Okay, so we use in the first experiment we use this sin value. So we need to use this sin value because it will change the potential energy of this puck because of the incline of this air table. So we use 0.1 sin value. Okay, now we are we need to know that how much center of this puck has gone distance. So we are putting this puck in the same point. So we are starting the experiment second value. Okay. Okay, now the puck has gone this the center of puck has gone this distance. We need to calculate the center of the puck. It is here, this point and this point. Okay, now it's nearly 7.6, so I'm using that 3.8. Okay, now we are using the same sin value, but we are gonna use different distance from. So in the first and second, we use this distance, but now we are going to use this distance. So okay, we are starting the experiment. Okay, now you need to calculate this center of puck. No, not here. Okay. The distance is 7.6, so I'm gonna use 3.8. So the center of puck has moved this much. So if you calculate this, 3.5. We found the value 3.5. So we need to put the value on this report. If you are, we need to put the value in your report, experiment report. Then we are going to. Then we need to calculate how much spring potential conserved and how much this potential have that. How much potential puck have in the first place. We need to know that. So you need to know the sinus values. Then you need to know how much the distance that puck go. You need to know these two. So after the calculations, we know that spring potential energy than normal potential energy. So we need to calculate the error percentage of this experiment and make error percentage. The reasons of error can be air resistance, or maybe it's not perfectly frictionless. This places it has it can we just doesn't the friction is too small. We are not thinking about the friction, but it can affect the error about that, or maybe you didn't adjust the air table perfectly, or it can has this error reasons. So it's maybe this tube can cause a bit error because of the while going there it's pushing the puck a little bit. So there are a lot of reasons for the error percentage. So what we learned is what we try to do in this experiment, we try to convert the potential energy to spring potential energy. Now we need there can be a bit error percentage, but in this experiment we see that if there is a perfect place, we can conserve the energy from the potential energy to spring potential energy. Thank you for listening to me. If you are doing this experiment, be careful about this balance of the air table, or you need to calculate the constant of spring. There are a lot of used tools in the internet or websites that you can use. So you need to be careful about the spring constant. You need to careful about the frictionness. So, for instance, there shouldn't be any particles that can affect your experiment. So, okay. Thank you for listening to me. Have a nice day.